Good morning. Welcome to today's webinar. So for the next 15 minutes, we'll take a little bit of a look at pattern polarizers and answer one central question: when does it make sense to structure the polarization, especially instead of using just one uniform linear polarizer across the full clear aperture? Briefly about myself, I'm Friederike Marschak. I'm the head of marketing and sales here at codixx. And if you have any technical or commercial question regarding after this session or regarding any of our products, you can find my contact details here on the slides. Please feel free to reach out via phone or just write a quick emails. Before we dive in, a little bit of housekeeping. Please keep your cameras and microphones off during the presentation to ensure a stable connection. If you have any questions, please post them in the chat at any time, and I would address those questions at the end at the Q&A session. So what is this challenge? The challenge is usually you have a standard polarizer, linear polarizer, which is uniform, but some of the optical systems are not. So the polarizer has one polarization axis. It's usually optimized for one specific wavelength range, but you might have a system which requires two or even more polarization axes, like 0 degree, 90 degree, plus 45, minus 45, have different wavelength ranges, like working if one beam in the visible range, one in the UV range. And one way to adapt is then you could use multiple polarizers, or use additional diaphragms or mask, or you add a mechanical element to your system to rotate the polarizer to get the axis that you always need. So, but it's sometimes not really suitable for your system. So sometimes it makes more sense to use a pattern polarizer, where you combine all these functions into one element. So what is a patterned polarizer? So a pattern polarizer or a structured polarizer is divided into multiple different segments or structured areas. All these different areas can have different optical properties. It could be different polarization axes, different wavelength ranges. There can be transparent areas without any polarization, or opaque or light blocking areas. Here in these pictures, you can see a little bit of what we've done so far for our customers. So it's a really versatile product. So why are codixx polarizers especially suitable for patterning? So our color polarizers, they have these silver nanoparticles at the, show you laser pointer here. We have these silver nanoparticles here, which are on both surfaces in the glass, but they are pretty close to the surface, which allows us to have a very thin, robust glass-based polarizer. We have a really high polarization accuracy, and because the silver particles are embedded in the glass, it's a really high axis accuracy and precision, and it's suitable for UV, visible, and infrared as well. To create a pattern polarizer, we have two different main ways to do it. One would be the mosaic technology, where you can see here on the right, we have make basically a large sheet, cut it down, and assemble it then again, and fix it between two additional glass sheets. This one has a benefit. You can easily get multiple different polarization axes or wavelength ranges combined. It is also, because we make everything here in-house, it's relatively fast and also more on the budget-friendly side. But because it's assembled individually, the segment size and shape and the number are a little bit limited. If it's really small segments, it's basically usually too hard to reassemble it again. For smaller segments, it's better to use the lithographic or laser technology, where again we have not really larger sheet, there's the final size of the polarizer, and then we can just take away some of the silver nanoparticles on the top or bottom or on both sides at the same time. And then we can stack those together again, different sheets with different polarization axes, and then we have one finished pattern polarizer. With the lithographic or laser technology, it really has a really high design flexibility. Free-form geometries are possible. You get a much higher resolution than with the mosaic technique. The limitations is a little bit because we stack the polarizers on top of each others. It's the stack may introduce a little bit of a parallax effect. And for one polarization axis, it needs to be one sheet, so it's always for the same wavelength range. So, but yeah, why should you consider this? The one benefit of the pattern polarizers, like I said, is the multiple polarization axis in one filter. For most of the products we've done so far, this is the main reason for our customers. Because they get to have fewer individual components, which reduces also the alignment effort. You don't for incoming inspection, you don't have so much to do. It's much faster in a production line. Also, you get a more compact optical design, and the alignment of each axis to each other basically is fixed. And it's a fixed relationship between the axis and the sensor or beam path. You can see here in the picture, these are actually 4 different polarization axes. Each segment has a size of about 60 by 60 microns. And this bigger part here, it's 1 cent coin, just a little bit as a scale reference. Another benefit is that you can integrate the light blocking areas. If you have stray light you want to suppress, or just to have fewer separate apertures or masks required, and you can have a clearly separated active and inactive optical areas. For example, in an optical sensor, only the defined measurement windows should receive polarized light, while the surrounding areas must be blocked. So instead of having the separate part, you could integrate it into the polarizer itself. Benefit 3 would be the custom geometry and layout. For example, in machine vision systems, requires sometimes several narrow access zones across an image field. And here you could, put everything together, maybe a circle, a rectangle, triangle, lines. It matters because so the optical element follows the system design and not the other way around. And you can integrate such complex shapes much more easier into any existing system. I want to mention this is especially good if you're have a small system, you have space constraints because everything is much more compact. Benefit for a higher function density and compactness. So we see several different options combined into one. You have the reduced installation space, fewer optical interfaces and mechanical parts. And in this picture here, this one we made for automatic assembly. So you have these crosses here in the corners, which was used for automated assembly to align the parts within the system much more easier. And it's simplified procurement and assembly again. Another one with benefit 5, which I mentioned at the start a little bit, you could combine different wavelength ranges. So instead of going for a really, really broad polarizer, you could combine different polarizers which are optimized for specific wavelength ranges. For example, UV and infrared range with an especially high extinction ratio or transmission segments. And again, you have one component that can support application-specific spectral requirements. And the polarizer layout can be matched to the detector or illumination geometry or even the beam path. And everything is really customized for your system. Another benefit which comes sometimes up with my customers is you have the same wavefront for multiple beams in the system. So if you have a multiple beam path, they can pass through one common optical element. Everything hits the same surface, and this helps to maintain a shared wavefront reference across the whole system. So all systems interact with this, all beams interact with the same substrate, and it offers improved optical consistency between each beam channel. Again, fewer component tolerances, and much easier alignment in a multi-beam or multi-channel system. So what do we need to know if you now have the idea, I want such pattern polarizers? So basically the checklist is everything I mentioned before as a benefit. The different wavelengths range or spectral ranges, the different polarization axes which are required, the segment geometry or minimum feature size, the clear aperture or outer dimensions, any transparent polarizing or opaque area would be helpful with a short drawing. And if you need any coating, marking, mounting, etc. So final takeaway, pattern polarizers can help reduce component count, structure polarization especially, and integrate the multiple optical functions into one compact element. If you'd like more information, you can visit our website or reach out to the sales team. And as you can see here in this picture, we've done lots of different things already. And we are happy to discuss your optical layout and evaluate which patterning approach fits best. So thank you for your attention. Now would be the time for your questions. Let me check if there are already some questions in the chat. Okay, I don't see any questions. Okay, then I don't really want to keep you much longer. Just as a brief outlook. So next month, I will talk a little bit about polarization axis accuracy and why it is important and should be taken into account. but we have other interesting topics for basically the rest of the year. So like polarizers in life science, yeah, which parts to consider if you're designing polarization for harsh conditions, or common mistakes we see being done during designing a system. Yeah, so lots of different questions to answer through the rest of the year. And thank you for your attention. As I said, please reach out. Let us know what your thoughts are, what your problems are. We are here to help. Thank you very much.